I want to introduce you to a new topic, that of polyatomic ions. So let's look first at the name. What do you think this means? Poly, many, atomic, atoms, but they're ions. So what does that mean? Many atoms grouped together that together form an ionic charge? Absolutely. All right. So what these are is these are big old groups of atoms that together they're covalently bound, meaning all of the atoms that are bound together are covalent. Okay? And covalent means that sharing of electron density. Okay? We'll learn a lot more about that later. All right? But these covalently bound compounds together work all together, and then the whole group has a charge. So it's not like sodium, where sodium just has Na with a little plus on it. It's these molecules together. So like sulfate, which is what you see right here, SO4. The sulfur is a nonmetal. The oxygen is a nonmetal. So they're covalently bound together. But then this whole group here has a 2 negative charge. And so that's why then this group ionically combined with potassium. Okay? Because now you have a group that is your nonmetals, and you still have your metal that is attached to it. And so when you're looking at polyatomic ions, it's the same way as you would do all of your ionic compounds. It's just now you've got a group. If you want, you can just kind of cover that up and just think about it as some group and then a charge. It doesn't matter what's inside, but you got to keep it together, okay? And then your charge goes on the outside. And I'll show you how to do that with these examples. So let's do them one by one, and let's go from name to chemical formula and then chemical formula to name, just to show you how it works. So with the name, sodium carbonate, the very first thing you should notice when you look at this name is that carbonate is not on your periodic table. That should allow you to go, boo, oh, I get it. Carbonate must be a polyatomic. Light bulbs go off, okay? So if the name is not on your periodic table, check your list of polyatomic ions. All right, so check that, find it, and then that should help you guide your name. So in this case, we have sodium, Na plus carbonate. Go look it up on your little list. You're going to need to memorize these. SOCO3, 2 negative. And what I sometimes do is I'll put parentheses around my group. All right, so carbon and oxygen are both nonmetals, so they're my group. There's 3 oxygens, 1 carbon. Put the little parentheses around them. That way, if you bring any subscript down, when you cross the charges, it is going to go on the outside of the parentheses. All right, now it's not going to matter because the plus is just a 1, so it's understood 1, so it's not going to change things. But if this were a 2, like we're going to do in a second, it could change things. So keep that group together. And you can keep those parentheses throughout if you want. All right, so now we write our formula, Na2CO3, and you could either put parentheses or not. It's up to you. For this example, you're going to need the parentheses, all right? Because this is an understood 1, you don't need it. And that's our compound. So if I ask you what's the chemical formula for sodium carbonate, figure out the charges, cross them, write the chemical formula. Okay, let's do another one. Calcium, Ca2+, phosphate, PO4, 3-, and now we cross those charges. So the calcium ends up with a 3, phosphate, I'm going to put those parentheses, gets a 2 on the outside, and you're done. Okay, it's really that simple and that complex all at once, all right? But you have to make sure, keep those parentheses, like every single time if you want, all right? This will help you keep it straight, because oftentimes I will see students put the 2 on the 4, and then this will either be like 42, or maybe they'll multiply them together, and now it's PO8, completely different compound, okay? Doesn't even exist, I don't think, okay? So don't do that, keep your parentheses. All right, then when you've got something like this, feel free to add in those parentheses. And now it can help you figure out the name of the compound. This is probably potassium, K+, sulfate, SO4, 2-. Does that work if I cross those charges? Absolutely. Okay, so now I just name them. K, potassium. Go find SO4, 2- on your chart, and it is sulfate. Don't change the ending. None of these need to end up in IDE. That's the other sign that you have a polyatomic ion. If you got 8 or ite, then these are going to be your polyatomic ions. All right? They are still going to be ionically bound between the cation and the polyatomic ion. Or you could also have like ammonia, where ammonia is the cation, it's the polyatomic ion, and then you might have some other anion over here. Okay, but they're covalently bound within the polyatomic ion, ionically bound between the poly and the other ion in the formula. All right, so that is polyatomic ions.